Okay, next one. So the first one, we're given f of x is 2 over x4 plus 5x, take away 3. So the first thing we have to do is rewrite it. So it's ready to use calculus. So 2x minus 4 plus 5x minus 3. Differentiate it. 2 times minus 4 is minus 8. Take away 1 from the power. And I just differentiate it to give me 5. Integrate it. So add 1 to the power is minus 3. Then divide by minus 3. So 2 over minus 2 over 3. Add 1 to the power. Then divide by it. So 5 over 2. Minus 3 becomes minus 3x. And stick a plus c at the end. Okay, good. That's that one done. Second one, we've got f of x is sine 2x, and we've got g of x is sine 2x at 60. And we want to figure out what the transformation is. Well, if I think about it, it's inside the bracket that's changed, so it's got something to do with x's. And all I'm doing to the x's is I'm adding 60. So it's f of x. Actually, if I did x at 60, let's look what would happen. Because that's what you might be thinking, just as I was about to tell you. So sine, I would do 2 times x at 60. So when I expand that outlook, I get 2x, add 120. So you can see why x at 60 wouldn't work. So instead, think what number can I put there? So when we expand it, we get the 60, and hopefully you'll see that's 30. So it's sine 2 lots of x at 30. Remember, brackets are key for these transformation questions. So expand that in the bracket, so 2x at 60, that works. So my transformation was x at 30, so it's inside, so that's x. It's opposite because it's x, so I'm going to take away 30, and it's a plus, so it's a translation, sorry, so it's translate in the x direction, so that's the top one, and it's the opposite, so it's minus 30. Okay, next one, number 3. Okay, so let me see the question. So it's x5 add 3x4 take away 2x squared plus 5x minus 2 all over x squared plus x minus 1. So it's just asking for division. So x squared x minus 1. So I'm going to put my x5 in first. So x3 goes to the top because x3 and x2 makes x5. So that gives me x4 minus x3. Okay, I want 3 x4s, so I need 2 more. So x squared times 2x squared. So I can fill in the next row, 2x cubed minus 2x squared. So now I've got minus x cubed, I have 2x cubed, so I've got 1x cubed. I want minus, sorry, I don't want any x cubes, so I need to take away an x cubed. So minus x is going to go on the top, so I can fill in that column. So I've got minus 2x squared, minus x squared, so I've got minus 3x squared, but I want minus 2x squared, so I need to add an x squared back on. So that's going to give me 1 at the top, so an x there, and minus 1 there. So now my remainder, I've got 2 x's, I want 5 x's, so 3x. I've got minus 1, I want minus 2, so I need to minus another 1. So my answer is x cubed plus 2x squared minus x plus 1 plus 3x minus 1 over x squared plus x minus 1. So A is 1, B is 2, C is minus 1, D is 1, E is 3, F's minus 1. Okay, next one. So geometric sequence, the second term is 5 and the ratio is 0.25. So second term is 5, so R is 5. We know what R is, so R times 0.25 is 5, so A must be 20. So times by 4. And we want the sum to infinity. Well, we get given that formula. So I know what it is. So 20 over 1, take what, 0.25. So type that in your calculator, and we get 80 over 3. And the last one. Sketch the graph. Y is 2, x plus 1 squared, x minus 1, x minus 2. Well, the roots, I have minus 1, 1, and 2. The y-intercept, I have 2 times 1 squared times the minus 1 times the minus 2. So that just gives me 2, so that gives me 4. And the shape, well, I'll get 2 times x squared times x times x. So that's 2x4. So that's an even power and positive. So it starts up here and ends up here. So it's going to do something like that. So put it all together, and we should have, if I rub that bit out, so minus 1's there, 2's up there, 1's there, 2's there. So it starts at the top, bounces on 1, minus 1, sorry, goes through 1, and then through 2. Then if we wanted to work out where these 10 points were, we could use calculus. We could differentiate it and make it equal to 0.